Functions are the basic infrastructure of C++ code. So the code is contained in functions. To execute that, you have to call a function. So C++ is remarkably flexible in the ways that you can define and call functions here. So you can define functions with a fixed number or parameters or variable number of parameters. So you can write generic code so that the same code can be used with different types. And you can even write generic code with a variable number of types here. So defining C++ functions, so at the most basic level, a function has parameters here. So it has the code to manipulate the parameters, and it has the return value. So C++ gives you several ways to determine these three aspects. In this next lecture, we will cover these parts of C++ function from left to the right of the declaration. So functions can also be templated, but this will be left to later sections. So a function must be defined exactly once. But through overloading, you can have many functions with the same name that differentiate by their parameters. So code that uses a function has to have access to the name of the function, and so it needs to have access to either the function definition or the declaration of the function, also called the function prototype. So the compiler uses the prototype to type check that the calling code is calling the function, so using the right types here. So typically libraries are implemented as separate compiled library files, and the prototypes of the library functions are provided in header files so that the many source files can use the functions by including the headers. So however, if you know the function name, parameters, and return type, you can type the prototype yourself in your file here. So whichever you do, you're simply providing the information for the compiler to type check the expression that calls function. So it's up to the linker to locate the function in the library and either copy the code into the executable or set up the infrastructure to use the function from a shared library. So including the header file from for a library does not mean that you will be able to use the functions from that library, because in standard C++, the header file does not have information about the library that contains a function. So most of the C runtime library is implemented this way here. So the function is compiled in a static library or a dynamic link library, and the function prototypes are provided in a header file. So you provide a library and a linker command line, and typically you will include the header file for the library so that the function prototypes are available to the compiler. So as long as the linker knows about the library, you can type the prototype in your code here. So this can save you from including some large files into your source files, the files that will mostly have prototypes of the function that you will not use here. So far in this course, we have used one source files, so all the functions are defined in the same file as where they are used. So, and we have defined the function before calling it. So that is, the function is defined above the code that calls it here. So here you do not have to define the function before it is used, as long as the function prototype is defined before the function is called here. So in main function, we're going to print something here, mult here, for example, cout mult. As you can see, we have to input the okay, std cout here, and as you can see, we got an error because we have to import the eostream header file, and as you can see, we can now print something on the string. So mult here, std, and 667 and inline here, and after that we're gonna create the mult function here. Mult here into, I will show you what's wrong with this code here. LHS here, and return the LHS multiplied by LHS here. So the mult function here defined after the main function here, but this code will here Let's try this out. Oops, actually, it's still there here. Here, this code will not compile because it's given the prototype before the main function. So this is called here, if we make it like that, as you can see here, the function can compile and it will multiply 6 by 7 here. So the prototype doesn't have to parameter names. So this is because the compiler only needs to know the types of the parameters, so their names. So however, since parameter names should be self-documenting, it's usually a good idea to give the parameter names so that you can see the purpose of the function here. Now here in this lecture, in this example, the function is defined in the same source file. So the internal linkage, this means there is an internal linkage here in this code. So if the function is defined in another file, the prototype will have external linkage, and so the prototype will have to be defined, for example, like this here, extern integer mode here, integer here. So the extern keyword is one of many specifiers that you can add to a function declaration, and in the previous lectures we have seen others. So for example, the static specifier can be used on a prototype to indicate that the function has internal linkage, and the name can only be used in the current source file. So current source file in this example here, for example, static integer. So you have to write static before the function return type here. So in this example, it is appropriate to mark the function as static in this case. So you can also declare a function as extern here, which affects how the name of the function is stored in the object file. So this is important for libraries and will be covered shortly.